Hey, what's up everyone? So you've seen the title. The idea for this evening is to take a sneak peek at the next features of Swift, so the features that will be released in the future as part of Swift 5.7. If it's the first time you follow one of my lives on the topic, just a quick reminder on how it is actually possible to be aware of the future versions of Swift before the release. And the reason is that Swift evolution process is something that happens at least partially in public. And so on GitHub, we have a list of documents called the Swift evolution proposals, in which evolution to the language are being pitched either by people working at Apple or by people from the community. And once these proposals have been implemented into the language, it's written in it. And so what I do for this live is that I select a few proposals that are written, that are marked as implemented for the next version, and we basically comment them. And as you might have seen on the thumbnail, we are going to cover two proposals this evening. We're going to cover one about opaque parameter declarations, and the second one about if-let shorthand for shadowing an existing optional variable. And of course, this title might sound a little bit mysterious, but we are going to make them much more clear during this live. And good evening, Flo, and good evening, everyone. And of course, the goal for this live is to be as interactive as possible. So any question that you have, please ask it in the chat, and I will do my best to try and answer it. And all that being said, let's get started with the first Swift evolution proposal, so the one about opaque parameter declarations. So let's just take a look here at the beginning. So we can see that the author is Doug Greger, so it's someone working at Apple and working in the Swift team. Review manager is Ben Cohen, also working on the Swift team. If you watched talks from WWDC about Swift, there is a very good chance that you've actually seen seen either of them in one of these talks. And so let's get started with the introduction. So Swift's syntax for generics is designed for generality, allowing one to express complicated sets of constraints amongst the different inputs and outputs of a function. For example, consider an eager concatenation operation that builds an array from two sequences. So we have a function, eager concatenate. It takes as argument two types that conforms each one to sequence, so sequence 1 and sequence 2, and it works where the element of sequence 1 is the same as sequence 2. So it's kind of like not merging two sequences, but concatenating actually, you cannot describe it better than this. And so there is a lot going on in that function declaration. The two function parameters are of different types determined by the color, which are captured by sequence 1 and sequence 2 respectively. Both of these types must conform to the sequence protocol, and moreover, the element types of the two sequences must be equivalent. Finally, the result of this operation is an array of the sequence's element type. One can use this operation with many different inputs so long as the constraints are met. So we can concatenate two sequences of ints, and you can see that we have both an array and a set, but it works because they both conform to sequence. We can concatenate dictionaries and arrays of tuples, and I guess it also works as long as the keys and the values are of the same type. And finally, here there would be an error because we cannot concatenate an array of ints and an array of strings because the types are not compatible. However, when one does not need to introduce a complex set of constraints, the syntax starts to feel quite heavyweight. For instance, consider a function that composes two SwiftUI views horizontally. So if we want to compose two views in SwiftUI, we need to say we have view1 and view2, and they are both generic types. And so we have v1 and v2, it returns some view, and basically we compose them. And what's interesting to see here is that we've had to introduce a generic argument for the arguments because we don't have yet the equivalent of the sum syntax for arguments, but of course that's the very purpose of this proposal, to introduce it. So there is a lot of boilerplate to declare the generic parameters v1 and v2 that are only used once, making this function look far more complex than it really is. The result, on the other hand, is able to use an opaque result type to hide the specific return type, which would be complicated to describe, describing it only by the protocols to which it conforms. So once again, I've just basically said what was after in the proposal, but the idea is that this syntax is much, I don't want to say cleaner or nicer, but shorter than having to introduce a generic type. And it's actually kind of equivalent. It's just like, we could say like some view is kind of saying I have an anonymous generic type. Conceptually, it feels kind of like the same thing, meaning that it basically has the same semantics, except that you cannot refer to it. So like you couldn't say some view.element equal some view, some other view.element, but as long as you don't need this, so if you are fine with keeping it anonymous, then it's kind of the same thing. I don't want to say it's exactly the same thing because I'm sure there is like one use case where it doesn't work, but you get the idea. So this proposal extends the syntax of opaque result type, so the sum view here, to parameters, allowing one to specify function parameters that are generic without the boilerplate associated with generic parameters list. Or we could also say introducing type erase wrapper, such as any view, for instance. So the horizontal function above can then be expressed as horizontal v1 sum view, v2 sum view, and it returns sum view. And we can notice that, of course, this wouldn't work for this eager concatenate because with the sum syntax, we couldn't express this constraint right here because, like I was putting it, some sequence would be kind of like an anonymous generic type. And then what they say, semantically, this formulation is identical to the prior one. So yeah, actually, when I was saying it's kind of the same thing, apparently it might be exactly the same thing, but it's simpler to read and understand because the inessential complexity from the generic parameter lists has been removed. It takes two views, the concrete type does not matter, and returns a view, the concrete type does not matter. What's interesting to understand is that when you say some view, it doesn't introduce what Swift calls an existential, meaning that the actual type here, the return type, is known by the compiler at compile time, and the compiler must be able to infer that type at compile time. Otherwise, you will definitely get a compilation error. Okay, so here this is Swift Evolution Threads, pitch for this proposal, easing the learning curve for introducing generic parameters, improving UI of generic pitch. So it's like threads on the Swift forums where that kind of topic were discussed. And so now we reach the proposed solution. So this proposal extends the use of the sum keyword to parameter types for functions, initializer, and subscript declarations. So most of the things that can take arguments, we can see that we don't have, for instance, associated types for associated values for enums. We will see if they come later. As with opaque result types, some P indicates a type that is unnamed and is only known by its constraints. So actually, when I was saying it's kind of like an anonymous generic type, it seems to be exactly that. It conforms to the protocol P. When an opaque type occurs within a parameter type, it is replaced by an unnamed generic parameter. For example, the given function here, function f takes an argument p of type sum p, is equivalent to a generic function described as follows with a synthesized type parameter. Synthesized is a very good word to describe it. And so, Flo, you are saying, for anyone who wants to learn more about existential, have a look at the video about the any keyword. And of course, as you can imagine, if you've heard about the any keyword added in Swift 5.6, the idea is that it's going to work very well when we have both the any keyword and the sum keyword that are available for arguments, because they will work very well together, like because it seems natural to use any and sum in ways that are like not mirroring, but to have them work in pairs, basically. Okay, so let me get back to the proposal. So note that unlike with opaque result types, the caller determines the type of the opaque type via type inference. For example, if we assume that both int and string conform to P, one can call or reference the function with either int or string. So we can call it Okay, so this is interesting because for the return type, when you use an opaque return type, opaque result type, there is only one type and it's known at compile time. But here, for the argument, it could be like several one, and we could say like it's kind of like the synthesized generic argument is kind of like specific to a call site, whereas for the result type, it's specific to a function declaration. It's tied to a function declaration. So here we can say it's okay to call it with an argument of int if int conforms to p. Same thing for string if string conforms to p. And also you can, not specialize, but you can like I don't know what is the right word, coerce maybe, but you can store a function with that signature into a variable that has this type, so where some p has been replaced by a type that is compatible with the constraint. But of course, if you store nothing, it's not going to work because it won't be able to infer the parameter. So then they talk about this proposal here, so which extended opaque result type to allow multiple use of some p type within the result type in any structural position. Opaque type in parameters permit the same structural use. So for instance, we can do encode any dictionary of pairs and say the dictionary. So the keys are some hashable and codable, and the values are pairs of some codable and some codable. Okay, not sure if this would be like a great syntax for clarity, but at least we can do it. And so you are saying, this is very interesting, that means that this behaves differently to how we used to know some in return types. I get that you don't want to add another keyword though. Yeah, it makes sense because the IDs are still the same. And in a way, it makes sense because the return types is always the same, but the argument could change. And I'm just thinking, like, before I say it, to see if it's correct or not, but it might also be linked to the fact that when you think about functions, the return type of a function is covariant, whereas the argument type are contravariant. So it might be linked to that actually also, but I am not sure, but I will try to check it afterward. But it might also be like not the reason, but the theoretical justification why you need this behavior. And so this is equivalent to basically, once again, introducing a generic argument each time. Okay, and each instance of sum within the declaration represents a different implicit generic parameter. Once again, I just keep getting ahead of what the proposal is trying to say. And good evening, Mohamed, and welcome on this live. So now we have the detailed design. So opaque parameter types can only be used in parameters of a function, initializer, or subscript declaration. They cannot be used in, for instance, a type alias or any value of function type. So for example, in a type alias, it doesn't work. But in a type alias, type aliases, they do support generic arguments. So it's like we can still achieve the same level of functionality, except we need to explicitly introduce a type. And the same thing here. Yeah, you cannot type a variable with some p. And I'm wondering, I think that closures, you also cannot use an opaque result type with a closure. You can also use it with a function. And it makes sense because in a closure, you could like then swipe another value at compile time, and so it's harder for the compiler to basically infer some invariant for the function. And there are additional restrictions on the use of opaque types in parameters where they may conflict with future language features. Variadic generics. An opaque type cannot be used in a variadic parameter. So variadic parameter, it's parameter that can take several values separated by commas. So typical example is a function like print, for instance. So here, this wouldn't work, and they say that this restriction is in place because the semantics implied by this proposal might not be the appropriate semantics if Swift gains variadic generics. One thing that would be really nice, variadic generics in Swift. Maybe we'll talk about it in a future live stream the day it is implemented in the language. Specifically, the semantics implied by this proposal itself without variadic generics would be equivalent to. So yeah, because if they added it, it would be equivalent to adding variadic generics. And if you're wondering about what variadic generics are, I won't talk about them, but just to show you, to give you a hint of why they are important. If you've ever wondered why you cannot add more than 10 views, I think it's 10. I don't know, yeah, I think it's 10, yeah. 10 views in a VStack, it's because Swift doesn't support variadic generics. Okay, and so here accept loss would require that all the arguments have the same type, something like this. With variadic generics, one might instead make the implicit generic parameter a generic parameter pack as follows. In this case, accept lots accepts any number of arguments, all of which might have different types. Okay, that part is a bit theoretical. Then opaque parameters in consuming position of function types. So the resolution of Swift Evolution Proposal 328, so let's just see what it was. It was structural. Oh, it's another one for, okay, so maybe we'll keep it for another live, but let's see if we can keep moving without understanding it. So for example, a function that returns, so this function f returns this function right here. And so you cannot use it in that way. And so the result of function f is fairly hard to use because there is no way for the caller to easily create a value of an unknown, unnamed type. Yeah, how do you create a value here? And the same prohibition applies to opaque types that occur within parameters of function types. So for instance, if we have a function g that takes another function as its argument, so typically, for instance, like think a completion handler, it cannot work also for completion handlers. And so the reasoning for this prohibition is similar. In the implementation of G, it's hard to produce a value of type sum p when a type isn't named anywhere else. So from what I understand, it's like it could build, but you could never call the method because you couldn't produce a value that conforms to some p because you have no way to reference some p, so it doesn't make sense to introduce it in the language. Is there already a release date for Swift 5.7 or do we expect it to ship with Xcode 14 beta 1? At that point, it's just a guess, but at that point, I would say like WWDC would be the most logical. Like Swift 5.6, it was in March and it wasn't announced like in a big Apple announcement. But yeah, I guess WWDC makes sense. But maybe they will drop it like ahead of WWDC. You never know. But I would say like WWDC, and probably at the same time they will talk a lot about the async algorithms package, which will be, I guess, and I hope, one of the big topics this year. So then we reach source compatibility. So this is a pure language extension with no backward compatibility concerns because all uses of some in parameter positions are currently errors. So basically, like, it doesn't break anything because before trying to use that syntax would lead to a compilation error. And so Swift code that is not valid Swift code. Effect on ABI stability. This proposal has no effect on the ABI or runtime because it is syntactic sugar for generic parameters, which from what I understand basically says that after compile time, this is basically like the sum p is consumed by the compiler to synthesize code, but it doesn't exist in the code at runtime, which makes sense because using sum p doesn't introduce an existential for the types that don't have one. For instance, protocols with associated types. And yeah, exactly. Like since the WWDC is less than a month away, I guess people at Apple are already like busy on other topics. So either something is ready and it will drop for some reason, maybe unexpectedly. But yeah, I guess WWDC is like the safest bet here. Effect on API resilience. This feature is purely syntactic sugar and one can switch between using opaque parameter types and the equivalent formulation with explicit generic parameters without breaking either the ABI or API. However, the complete set of constraints must be the same in such cases, which make sense. And what they're saying is that you could basically like use an explicit generic type, then use some instead, then go back to a generic type, and your code would still work. Future directions. Always interesting to take a look at this. How could this proposal evolve in the future? So constraining the associative types of a protocol. So this proposal composes well with an idea that allows the use of generic syntax to specify the associative types of a protocol. For instance, where collection string is a collection whose element is type string. And it's true if we want to express this ID in Swift today, we have to write a type that conforms to collection where t.element, for instance, equal string. And if we could use this shorthand syntax, it would be shorter and I guess also clearer. So combined with this proposal, one can more easily express a function that takes an arbitrary collection of strings. So by saying some collection of string, and remember currently, if you use some, you cannot express a constraint on an associative type of the generic argument, because the generic argument is synthesized, is anonymous, and you don't have a way to refer to it. And yeah, it could be like interesting, like it could be a good question. So rewriting an opaque parameterized function to a function with generic constraints, I guess not for like junior developers, but for someone that is like a bit senior and that maybe like said on their resume or on their interview that they have like strong focus on the Swift language, it would make sense, definitely. Okay, then they say recall the complicated eager concatenate example from the introduction. So that one here, with opaque parameter types and generic syntax on protocol types, one can express this in a simpler form with a simple generic parameter representing the element type. So saying we have a generic type t, and then we say some sequence of t and some sequence of t, and it is implied that the first element of the sequence is the same than the element of the second sequence because we've used the same generic argument. But remember, once again, this is not something available in Swift 5.7. This is something that's being like discussed. It's being hypothesized for the future, but this is not going to drop in Swift 5.7, unfortunately. And in conjunction with opaque result types, we can hide the representation of the result. For instance, yeah, and you can also use it with the result. So you can make like the constraint transition, not transition, but be used both in the arguments and in the return type, which is pretty nice. And so, Yash, you are saying, I'm not even a junior yet, but I feel like having a decent grasp on advanced Swift features, mostly just because I like looking through Swift evolution. And indeed, that's what I meant by more like senior, is that if someone takes a look regularly at the Swift evolution proposal and forum, which is a great thing to do, they're going to like know that topic better, but at the same time, someone who doesn't and maybe had a more like hands-on approach for a junior role, I think like there isn't one that is better than the other. Like it's just two different preferences. So that's why I was more thinking about it for a senior. But on the other hand, a junior that knows about this, it's definitely like a big advantage, most definitely. Then what do we have? We have enabling opaque types in consuming positions. So the prohibition on opaque types in consuming position could be lifted for opaque types both in parameters and in return types, but they wouldn't be useful with the current semantics because in both cases, the wrong code, caller versus callee, gets to choose the parameter. We could enable opaque types in consuming position by flipping who gets to choose the parameter. To understand this, think of opaque result types as a form of reverse generics. It's getting complicated here, where there is a generic parameter list after a function's arrow, so return type, and for which the function itself, the callee, gets to choose the type. For example, function f1 returns some p translates to reverse generics version. So a function f1 returns something that return something generic. And here it would be the callee implementation here that picks the concrete type for P. So by call-ly, they mean that it would be inferred at the call site, I guess. And the problem with opaque types in consuming positions of the return type is that the callee picks the concrete type and the caller can't reason about it. We can see this issue by translating to the reverse generics formulation. So function f2 that returns the function that takes some p and goes to void, it translates to reverse generics version. So it returns something that takes this argument, okay? And we could flip the caller callee choice here by translating opaque types in consuming positions to the other side of the arrow. For example, f2 would be translated into, so if we flip opaque types in consuming position, so putting the argument here this time, this is a more useful translation because the caller picks the type of T using type context and the callee provides a closure that can work with whatever type the caller picks generically. For example, so here int, so this would work because T would be int, and here it would also work because T would be string. Okay. And you're saying callee is the function. Yeah, I must say this part, it feels a bit like it's written by compiler engineers and maybe also for compiler engineers because I have a harder time like getting my head around it, but it's always the same. I feel in the discussion about like proposed future directions. But here, I guess this would be like the callee here, and the idea that they're saying is that when you declare the function, you say that you return something that takes some p, and then it would be like at the call site, so the place that will actually call, the method that would decide whether it makes sense to use an int or a string. But I'm just thinking like if we're not missing yeah, what do we mean by consuming function? I think by consuming function, they mean like functions that are either like taken as argument or a function that returns a function. For instance, like I guess a completion handler, or maybe, I don't know if Combine has this approach, but Eric Swift used to have it when you wanted to configure um, like or to bind a table view. You would take your items and it would like return a configuration method that you would pass in to the table view. But it's a bit complicated to get your head around it without like good code examples. And here the code examples, I feel like for people who already know, they're great, but they're not that great at making it clear if you don't already know like what are the concepts being discussed. And you are also saying, are opaque parameters and if-let shorthand confirmed for Swift 5.7? Because it says status. So yeah, when it says implemented, as far as I know, it means that it's already implemented and it's part of the next release. So we could say like it's ready for the next release train. Okay, so that part right here, not gonna lie, it's a bit complicated. So I'm looking like, yeah, it's already been like half an hour on this proposal. So I will move to the other proposal because that part is more complicated and it's more like talking about future direction and it's not very actionable. So I'm going to move on, but first let's get some water. And moving on to the next one. So if-let shorthand foreshadowing an existing optional variable. And this one I think is going to be very, very popular and used in Swift. So let's just take a look. The author is Carl Stephens. And let's just see like, is it someone that works at Apple? No, it's an iOS engineer at Airbnb. So it seems that this proposal was made by the community rather than by someone at Apple, which like Yeah, reminder, if you have an idea for language evolution, you can propose it and it can be accepted. And a great example of community proposal that was also like a community proposal that was also like very simple is the toggled method on Boolean. It was proposed by Chris Idoff, so who is running the website objective-c.io, and that is not working for Apple, and this is part of the community. And he made that proposal, I think it was in 2016, if I remember it correctly. And yeah, very simple proposal, but it was accepted, and now it's part of the language, and it's used by a lot of people. So if one day you have an idea about an evolution for Swift, making a proposal is definitely a good idea, even though you need to have the time to write the proposal and then defend it on the Swift forums. So let's see the introduction. So optional binding, so using the if let variable equal variable syntax to create an unwrapped variable that shadows an existing optional variable is an extremely common pattern, and I think we can all agree on the word extremely here. This pattern requires the author to repeat the reference identifier twice, so here and here, which can cause these optional binding conditions to be verbose, especially when using lengthy variable names. We should introduce a shorthand syntax for optional binding when shadowing an existing variable. So for instance, we have the existing variable foo here, and we do if let foo, and inside this scope right here, foo is now a variable of type non-optional foo. So if you've ever taken a look at some Kotlin code, in Kotlin they have a feature called smart casting, and it's very, very similar feature. And you're saying, Flo, that you're really looking forward to this one. Is it needed? No. Will it be used all the time? Yes. And I would even say, like, is it needed? Kind of, in a way. I mean, now I think Xcode suggests generating the name of the other variable, but uh, definitely like even better. The question is, will there be a migration tool to migrate all the existing code to this new syntax? And if so, what will be like the number of files changed in the git commit that applies it? And also, I'm curious now to see if this will also apply to guardlet, or if it will be only iflet. Like, if it's only iflet and not guardlet, yeah, it will be like not that it will suck. No, I'm starting to exaggerate, but like if it's only iflet and not guardlet, it will be like maybe like stopping halfway there. But we will see like if it's the case, and maybe if it isn't, there is actually like a good reason for it. Okay, let's keep moving. So the motivation. Reducing duplication, especially of lengthy variable names, makes code both easier to write and easier to read. For example, this statement that unwraps some lengthy variable name and another important variable is rather arduous to read and was without a doubt arduous to write. So we have the two variables here, and then we have the iflet, and the name is being repeated. And with code completion, like it's easier, but without code completion, of course, you also run the risk of making a typo in your code. And yeah, definitely, like, there is nothing wrong with more syntactic sugar as long as it like doesn't hurt the readability of your code. But here, it's definitely not the case. So one approach for dealing with this is to use shorter, less descriptive names for the unwrapped variables. So here is just A and B. This approach, however, reduces clarity at the point of use for the unwrapped variables. Instead of encouraging short variable names, we should allow for the ergonomic use of descriptive variable names. So proposed solution, if we instead omit the right hand expression and allow the compiler to automatically shadow the existing variable with that name, these optional bindings are much less verbose and noticeably easier to read write. So here it would look like this. So you just say if let the name of the optional variable, and inside the scope you have access to an unwrapped version of the variable. So you have an unwrapped variable that shadows the existing variable. And variable shadowing, just to explain the name, it's whenever in a scope you have a variable that has the same name than an other variable available in the outer scope. This is a fairly natural extension to the existing syntax for optional binding conditions. So detailed design, specifically, this proposal extends the Swift grammar for optional binding condition. This is currently defined as optional binding condition. It's a let pattern initializer or a var pattern initializer, and it will be updated to let and the pattern initializer optional, and same thing for a var. So I guess, yeah, it's the initializer that has become optional. So the initializer is the equal something part. This would apply to all conditional control flow statements. So we have if let, we have else if let, we have guard let, yes, and we have while let. This one is less commonly used, but it also exists. The compiler would synthesize an initializer expression that references the variable being shadowed. For example, if let foo is transformed into if let foo equal foo. So just like, and it's a nice coincidence actually that just like with the opaque parameter types, the compiler is synthesizing things for us. So once again, these two proposals, they implement something that is purely syntactic sugar. Explicit type annotations are permitted, like with standard optional binding conditions. So for example, if let foo and then writing the type explicitly, it's transformed into here, and we can see that what is added is the initializer part here. The pattern following the introducer serves as both an evaluated expression and an identifier for the newly defined non-optional variable. Existing precedent for this type of syntax includes closure capture lists, which work the same way. So in a closure, if we capture if we capture foo inside the closure, foo is both an expression because it's the expression being captured by the closure, and it's also an identifier because it's a variable we can use inside the closure. So this already exists in Swift. Because of this, only valid identifiers would be permitted with this syntax. For example, this example would not be valid because this is not a valid identifier in Swift. So even though this property bar would exist on the variable foo, this syntax, so a string of character, then a dot, then a string of character, is not a valid identifier. And by identifier, they mean basically name of a variable. So this wouldn't be allowed. And in that case, you would still need to explicitly provide a variable name if you're interested in having an unwrapped version, an unwrapped variable that references the result of this expression. Interaction with implicit self. Like with existing optional bindings, this new syntax would support implicit self references to unwrap optional members of self. For example, the usage in this example would be permitted. So we have Swift UI view, so user view. We have the name and the email address, which is optional. Then in the body, so you have the text and for the name. And if you want to also display the email address, so you do an if let, and it's the same than writing this, which unwraps actually self.email address. So they're saying basically, if the property is a property of self, you can have self be implicit and it would still work. Okay. What's interesting is that we are reaching the source compatibility, but actually, like, you don't see the scrolling indicator, but we are only at like a third of the, a third or maybe half of the proposal. So I guess there are a lot of discussion either on future directions or on alternatives that were considered, and it's going to be interesting to read them. So source compatibility, this change is purely additive and does not break compatibility of any valid existing Swift code. Same thing for ABI stability and for API resilience, which makes sense because it's adding a new syntax. So any kind that already followed this new syntax was not valid Swift code. So future directions. Optional casting. A natural extension of this new syntax could be to support shorthand for optional casting. So for example, if let foo as question mark bar would be equivalent to if let foo equal foo as question mark bar. This is not included in this proposal, but is a reasonable feature that could be added in the future. So maybe if the new syntax proves to be popular, which I guess is going to be the case, it could be a future addition for the language. Or maybe they won't do it because they could also say like writing code like this might not be the best pattern, so making it too easy could also be seen as a bad thing. So I can imagine the discussion there could be, but at least it's a possible direction. interaction with future borrow introducers. What the hell is a borrow introducer? We are going to learn, I hope. So a roadmap for improving Swift performance predictability. Let me take a look at this document. What is this? Oof, we are back on light mode. It's going to kill my eyes. I'm just going to add it to the reading list for later. Discusses potential new ref and in-out introducers for creating variables that borrow existing variables without making a copy by enforcing exclusive access. For consistency with let var, it will likely make sense to support optional binding conditions for these new introducers. So I guess in an introducer, it's a keyword that is the same than let and var. And so it would be a ref or an in-out. Okay. But I guess this is like a bit in the future for Swift, and also maybe like aimed at code that is like a lower level than your typical application code that uses a Swift UI or UI kit. The shorthand syntax for let var optional bindings would extend fairly naturally to these new introducers. So like this here and like this there, which makes sense. But once again, if you're not like very knowledgeable like I am on the topic of what a ref and an in-out is, even though I can imagine like roughly what it is, yeah, it's hard to go like further on the topic. And no, I'm on Safari, but I think there is a dark mode on the Swift forum, but I guess you have to like activate it explicitly. But yeah, like the light mode is pretty awful when it's like shows up unexpectedly. So then they're talking about unwrapping nested members of objects. So remember, this proposal doesn't permit shorthand unwrapping for members nested in other objects. For example, this syntax right here, as we saw a few minutes ago, wouldn't work with this new syntax. There are a few different options that could allow us to support this type of syntax in the future. One approach could be to automatically synthesize the identifier name for the unwrapped variable in the inner scope. For example, if let foo.bar could introduce a new non-optional variable named bar or foo bar with some kind of like convention on how to capitalize and how to compose the several parts, we could say, of the expression. Another approach could be to permit this for potential future borrowed introducers ref and in-out. These borrows would have compiler enforced exclusive access to the underlying storage, so they technically do not require a unique identifier name for the inner scope. This could allow us to unwrap members of objects without any new variable or copies. So this would be allowed, I guess, because ref and in-out, they have a bit of a different semantic than let and var. And so you're saying flow, ref doesn't exist yet, right? Yeah, no, for me, it definitely like doesn't exist yet. And in-out, it exists, but kind of like as an attribute of an argument, but not as a variable type, I guess. But even though the correct word is introducer and not type, but you see what I mean. And so you were also saying in-out already exists, but is rarely ever used, at least for me. That's true, because you use it as you're mentioning it just after. Basically, in-out, it's about performance. The point of in-out, and actually I'm thinking, I don't think I've ever made a video on in-out, even like back in the days of the Swift tips videos. Like if one day I want to bring back a Swift tip video, in-out could be nice. And in-out, the point of in-out, it's that it's going to you can modify the argument. But I was about to say it doesn't do a copy on the right, but actually I think it does, because in-out it creates a local copy and then copy it back to the value. But yeah, in-out it's just to be able to modify an argument, and I think it can make sense in some instances for like performances. The typical use case is when you pass in an array. If you pass the array as in-out and then you append to it, I guess it's going to be cheaper than passing the array into a new array, which is going to like require a copy of the memory. But I might be wrong, because always remember that optimization is a very technical topic, and it's very easy to get it wrong when you're doing it like without all the proper like homework before. Okay, alternatives considered, and like I think there is some of them. given all the page that is left to be scrolled. So there have been many other proposed spelling for this feature. So the briefest possible spelling for this feature would be just a bare if foo condition, so not even a let keyword. This spelling, however, would create ambiguity between optional unwrapping conditions and Boolean conditions and could lead to confusing, counterintuitive situations. So yeah, what do we do if we have an optional Boolean? Definitely, I can imagine the logic, but I guess the let keyword is still important, both for like the to make the code clear basically, because without it, like shorter doesn't mean clearer. At least like the two of them definitely don't correlate. So it makes sense that they decided that to avoid this ambiguity, they need some sort of distinct syntax for optional bindings. If unwrap foo, another option is to introduce a new keyword or sigil for this purpose, like if unwrap foo, if foo question mark, which is kind of similar to a syntax we can use, for instance, when we do pattern matching with optional values. If have foo, a key benefit of introducing a completely new syntax like if unwrap foo is that it gives us the opportunity to also revisit the semantics of how optional binding conditions actually work. Today, optional binding conditions always make a copy of the value. From a performance perspective, it would be more efficient to perform a borrow instead of a copy. So that's a good point. Like if you are doing an optional unwrap on a value that costs a lot of memory to copy, it could have an impact, even though most of the basic type of the language implement copy on the write, which would prevent the issue if you're not modifying the value, which you can't with a let, but with a var you could. And so once again, this same roadmap discusses potential future introducers ref to perform an immutable borrow and inout to perform a mutable borrow. So for consistency with let var, it will likely make sense to support optional binding. Okay, that's what they were saying a bit before. Instead of being shorthand for if let, this new shorthand syntax could instead be shorthand for if ref. This would improve performance in general and could nudge users toward using borrows instead of copies, since only the borrow form would receive shorthand sugar, which makes sense. Like if you have a new syntax, uh, and you want people to use it because you think it's going to be better, make it easier to use than the existing syntax, and it will indeed nudge users toward using it. A key downside of borrows, however, is that they require exclusive access to the borrowed variable. Memory exclusivity violations will result in compiler errors in some cases, but can also manifest as runtime errors in more complex cases. For example, so here we have a variable x. We have a function that increments it, and what happens if we borrow? So we take a borrow on x and we call increment with this borrow as an argument, given that the function inside is also modifying this variable. This would trap at runtime, which means would crash, because increments by would attempt to modify the value of x while it is already being borrowed by the if ref x equal x optional binding condition. Once borrow introducers are added to the language, seeing ref x or inout x anywhere in Swift will serve as an important visual marker about the exclusivity requirement of the code. On the other hand, a new syntax like if unwrap x doesn't explicitly indicate that the variable is being borrowed. This could lead to users being surprised by unexpected exclusivity violations, which would cause confusing compile time error or runtime crashes. And when I read all of this, I definitely agree with the people that say that Swift is turning more and more, is becoming more and more like C++ by adding all of these new features. Borrow introducers will be very useful, but adopting them is a trade-off between performance and conceptual overhead. Borrows are cheap but come with high conceptual overhead. Copies can be expensive but always work as expected without much extra thought. As always, performance and simplicity being always like the two sides of a trade-off. Given this trade-off, it likely makes sense for this shorthand syntax to provide a way for users to choose between performing a copy or performing a borrow rather than limiting users to one or the other. And you were saying flow. I agree, other languages do support this though. For instance, JavaScript allows to check if something is not null like this, right? Haven't written. Um I think I'm not sure like if in JS you have like a shortened syntax, you have the is not null of course, but it's possible that for instance that TypeScript, which basically like compiles or like transpiles, I'm not sure what is the correct word, but that generates JavaScript in the end. I think they must have that kind of like modern features. And so, additionally, for consistency with existing optional binding conditions, this new shorthand should support the distinction between immutable and mutable variables, combined with the distinction between copies and borrows. That would give us the same set of options as normal variables. So, if let foo, if var foo, and potentially if ref foo, if in-out foo. And this is definitely a bit complex and also like very like prospective. Oh, and talking about if, yeah, definitely. Like, and in JS, you also have like null, and you have the case of undefined. I am sure there is a difference between null and undefined, but I am not sure what it is. But you have like that special case to also keep in mind. And so we were here, and since we already have syntax for this concept, we should reuse that syntax in the shorthand rather than create a new syntax that is less expressive. So that would only support a subset of the available options and less explicit. So basically, they're saying this to say like, let's use the introducer, so let var, ref, and in-out because it's more clear than introducing new like keywords like unwrap, where you're actually not sure what is going to generate, what kind of variable is going to generate. Okay, another option is to include a question mark to explicitly indicate that this is unwrapping an optional using if let foo question mark. This is indicative of the existing case let foo that was I was referring earlier, that is for pattern matching syntax. If let foo equal foo, the most common existing syntax for this, unwraps optionals without an explicit question mark. This implies that the conditional optional binding is sufficiently clear without a question mark to indicate the presence of an optional. If this is the case, then an additional question mark is likely not strictly necessary in the shorthand if let foo case. While the symmetry of if let foo question mark with case let foo question mark is nice, consistency with if let foo equal foo is even more important, considering they will more frequently appear within the same statement. Indeed, you might have the new shorthand syntax and we could say like the legacy or the traditional syntax when you want to refer to nested properties, for instance, and it would feel weird if the first one had a question mark and not the second one. And this is very interesting because it shows like when you want to introduce a new feature to the language, you need to manage a trade-off, and to do it, you need to find an argument that is going to support one approach over the other. And here, I think they produce like a very interesting argument. Additionally, the question mark symbol makes it trickier to support explicit type notations like if let foo of type foo, because if let foo uh, colon is colon foo is a natural consequence of the existing grammar, it's less clear how this would work with an additional question mark. Do you put it after the identifier? Do you put it after the type? It likely makes the most sense to put it after the identifier, but doesn't match any existing language constructs. And the last one, if foo is not nil, so similar to the smart casting in Kotlin. So one somewhat common proposal is to permit nil checks. So if foo is not equal to nil, to unwrap the variable in the inner scope. Kotlin supports this type of syntax. So if you test for foo not being null, then inside the scope, the compiler will assume that foo is non-optional. And it's the same thing for casting to another type also, which is quite a nice feature of Kotlin. However, this pattern in Kotlin does not define a new variable. It merely changes the type of the existing variable within the inner scope. So mutations that affect the inner scope also affect the outer scope. So what they say is that it doesn't create like a local constant, but rather you can still mutate the variable if you want. So this is different from Swift's optional binding condition because it's an if-let, as the name suggests, which defines a new separate variable in the inner scope. This is a defining characteristic of optional binding conditions in Swift, so any shorthand syntax must make it abundantly clear that a new variable is being declared, hence the use of the keyword let. Also, they could have decided to not permit if var foo. So since if var foo equal foo is significantly less common than if let foo equal foo, actually I have a hard time remembering the last time, if any, I have used this syntax, we could potentially choose to not support var in this shorthand syntax. Var shadowing has the potential to be more confusing than let shadowing, because var introduces a new mutable variable, and any mutations to the new variable are not shared with the original optional variable. So it's only like the mutations are only for the scope, so which is indeed not weird, but potentially counterintuitive. On the other hand, if var foo equal foo already exists, and it seems unlikely that if var foo would be more confusing, less clear than the existing syntax. Since let and var are interchangeable elsewhere in the language, that should also be the case here. Disallowing if var foo would be inconsistent with existing optional binding condition syntax. If we were using an alternative spelling that did not use let, it may be reasonable to exclude var, but since we are using let here, var should also be allowed. And thank you, Flo, for attending the live stream. And actually, like, we are close to the end because we have reached the end of the document, so you won't be missing a lot. And because we've reached the acknowledgement, so the author is thanking Craig Hockenberry, who recently wrote about this topic in Let's Fix If-Let Syntax, which directly informed this proposal. Thanks to Ben Cohen for suggesting the alternative if-let foo spelling and for providing valuable feedback on this proposal during the pitch phase. Thanks to Chris Latner, so the creator of Swift, for suggesting to consider how this proposal should interact with the upcoming language features like potential ref and in-out borrow introducers, which we discovered together this evening because I wasn't aware that these were potential future features of Swift. Thanks to Tara for suggesting the alternative if foo spelling. Thanks to John Shear for providing the SwiftUI optional binding example. Thanks to James Dempsey for providing the consistency with existing optional binding conditions example. And thanks to Frederick Kellinson-Lin for pointing out that variables in closure capture list are an existing precedent for this type of syntax. And this acknowledgement list has one advantage, one benefit, is that it shows that getting one of these addition to the language approved is a teamwork, generates a lot of feedback, a lot of like back and forth. And so if one day you want to make a Swift version proposal, expect to have like that kind of feedback and discussions happen on your proposal. And you're saying, Yash, have you seen SC357? Hope it gets accepted because I'm dying for a better string processing and collection operations. Well, I will make a screenshot to remember, take a look at it after the live stream, but I don't think I've taken a look at it. And we've reached the end of the second proposal I wanted to talk to you about this evening. So this is the end of this live stream. Thank you for following it. So this evening we've learned about two future features of Swift using what is called opaque parameters. So basically the keyword sum for arguments, and the new if-let shorthand syntax to declare an optional binding. And hopefully these new features, they should be available in the new version of Xcode that will be released. The beta will be released at WWDC, so in less than 1 month from now. And that being said, I think I just have to say, like, thanks again for attending. Good evening, good rest of your day, depending of where you are in the world. And thank you for watching, and see you next time. Bye.